Yes, hello class. Is this audible?
Yes, ma'am.
Good evening, Fahad. All right. So in the last class, we had started with dipole moment. So dipole moment was what? Just a quick revision of it. See, dipole is what? Dipole, if you have two charges with you, both of them should have the same magnitude but opposite signs. Means if one charge is positive, the other charge has to be negative, and both of them should have the same magnitude. Then you call it as a dipole. So the strength of that dipole, we call it as a dipole moment. If two charges having the same sign, same magnitude, opposite signs, are separated by a small distance, let's say 2a, then their dipole moment is given by P is equal to Q multiplied by 2a. Q is the charge, 2a is the separation. So it's a vector quantity whose direction is given by from your negative charge to the positive charge. This is the direction of your dipole, and the SI unit becomes coulomb meter. So we had also done a question where we had seen how to apply the formula. Now, you have two cases in your syllabus whose derivation do come in your examination. In your board exams also, this derivation comes. Electric field, if you have to know for a dipole, if it is located on two cases. One is on axial line, other one is on equatorial line. So these are important derivations. See, electric field on axial line of electric dipole. Now, how to identify whether a point is lying on the axial line or it is lying on the equatorial line? See, you have a dipole. Let's say this is plus Q charge, this is minus Q charge. This is your dipole that you have. Now, if I extend this will be the axis of it. If any point is lying on this axis, I'll call it that this point is lying on the axial line of the electric dipole. This is your dipole that you have, plus Q and minus Q. Plus Q and minus Q is your dipole. Now, if you extend this axis and a point is lying and you have to calculate electric field on that point, then you say electric field on axial line. So let's say I have taken a point A. This is a random point A that I have taken. So the separation is 2A between them. So from the center of dipole, this separation will be A, this separation will be A from the center of the dipole. This point here, I have to calculate the electric field. So firstly, I have identified that it is lying on the axial line. Reason? Because if you extend the axis, the point is lying on the axis of it. So your point is here lying on the axial line. Now, calculation of electric field, there's a small derivation for it. This is an important derivation. Electric field on axial line and electric field on equatorial line do come in your exams. So see, electric field, because of this positive charge. See, this is a positive charge, this is a negative charge. Can anyone tell me, if you remember, we have discussed electric field's direction for a positive charge. Is it away from the charge or towards the charge?
Away.
Away from the charge. Good. Reem and Samya, good. See, away from the charge will lead to where? If this is my point, away from the charge will lead me in this direction, moving away from it. So this is electric field due to the positive charge. And for the negative charge?
Towards it.
Towards it. Negative charge means moving towards the charge. So this is minus Q. It means this will be the direction of electric field, E minus Q. Now I have electric field's direction with me. Now I have to write down the net electric field. Net electric field will be what? Sum of electric field of both the charges, E negative and E positive. Now, E negative, this is E positive and this one is E negative. Now, if I have to write down the electric field for a point charge we have done. Okay, do you remember electric field for a point charge? If you have a point charge, then how do we write the electric field? Q charge is there. KQ by R. This is your formula for electric field for a point charge. All right. So if you have electric field for a point charge, the formula is KQ by R. Don't forget the formula. For force, it was KQ1 Q2 by R square on application of Coulomb's law. For electric field, it will be what? KQ by R. Then keep on revising the formula, because when we'll reach potential, then the formula gets added up. So for potential also, you have a different formula. So electric field, it is KQ by R, if you have forgotten. So see, this separation is A, this separation is A. From the center of dipole to this point, I have marked another separation R. Or let's take it as R. I have taken this separation. Now electric field E minus, this will be what? K for positive charge. Okay, let's take it for negative charge. Charge is Q, so this becomes Q divided by, what is this separation? Can anyone tell? Let's say this point is A, this point is B, this point is some P point. Look, this is R, this part is A, so this part will be not B, Fahad, R, small r. We have taken that separation as R. So good. Yes, R minus A. This separation will be what? This separation will be R minus A. No, completely R was there. We have subtracted this small a. So leftover portion will be what? R minus A. So this will be R minus A whole square. Remember, electric field due to point charge is KQ by R square. So KQ by R square. This is your electric field. So for the positive charge, it will be KQ divided by. Now look at the separation of positive charge and the P point. What is that total length? Not 2A. 2A is the separation between positive charge and negative charge. Separation between, look at the separation between this point, P point, where we are calculating the electric field, and this positive charge, this whole separation. Till here it is R, till here it is A. So it should be, try. From the center to the point, we have small r. And that additional distance is A. So total distance becomes what? Yes, Fahad, try. Not A square. Anyone else? Samia?
R plus A.
R plus A. Good, good. So why you were not trying? Correct. It would be R plus A. See, Fahad, A square it won't be. This is R, this is A. So complete becomes what? This whole distance becomes what? R plus A. Clear to all of you? Why are we taking this distance as R plus A?
Yes, ma'am.
All right. So this will be KQ divided by R plus A whole square. Now you have the electric fields with you. Just add them. Just add them. Yes, R plus A will be R plus A. That is right. So electric field, this will be KQ by R minus A whole square plus KQ divided by R plus A whole square. So let's take KQ common only from here. If you take KQ common from here, you will be left with 1 by R minus A whole square. Plus you will be left with R plus A whole square. Now see, let's take the LCM. Since we are getting it in the denominator, let's take the LCM. So electric field will be what? KQ we have already taken common and we have taken the LCM. So it will be, this would be R square. We are just opening the bracket. Taking the LCM will what? You have to multiply it with R plus A whole square. Okay, I'll open the bracket in the next step. This will be r plus a whole square plus r minus a whole square divided by r minus a square r plus a square. Now, if you are able to recall in your lower class, especially in 8th standard, you must have done this. A square minus b square. Do you remember this identity, a square minus b square? This is equal to what?
A minus B, A plus B.
A minus b multiplied by a plus b. Good, Samya. So similarly, if you see in this r minus a whole square, we are able to identify that identity. It means that denominator can be written as what? The denominator can be written as r square minus a square. That's why we have written it as r minus a whole square plus r plus a whole square. This identity, a square minus b square, is a plus b multiplied by a minus b. This is your identity. So since this is your identity, but here we have additional square, so we'll square it. And let's open the numerator. This will be r square plus a square plus 2ar. Here it will be minus r square minus a square plus 2ar. And here we were having kq, and this was electric field. Now, if you see r square, a square, r square, a square, this is getting cancelled only. And if you add this, you're getting what? Electric field. This is kq 4ar divided by r square minus a square to the power whole square. Now, can I write it in this manner? If I take 2 out from this 4a, I'll be getting q 2a, then 2. See, if I write it in this manner, there won't be any difference. If I multiply 2 with this 2a, I'll get this 4a back. So there won't be any difference if I separate this 2. Divided by r square minus a square to the power whole square. If I have written this, can't you tell me what is this q multiplied by 2a equal to? Dipole moment. That is equal to the dipole moment. So we have identified the dipole moment. This q multiplied by 2a is your dipole moment. See, we did it in the previous class. Charge magnitude multiplied by the separation between the charges. That gives you dipole moment. So this becomes what? 2k PR divided by r square minus a square to the power whole square. Clear? This is your dipole moments equation. R is what? I am repeating. R is the separation of the point from the center of dipole. See this. R was what? We had taken R as the separation of the point to the center of dipole. This. A is what? A is the half of separation of dipole. 2a is the separation between dipoles. So A is what? Half of the separation of dipole. R is what? R is center separation of dipole to the point that we have taken. See, in this you have one more thing I'll tell you. You have one approximation that makes your calculation very easy. It makes your calculation easier. That is known as ideal dipole approximation. Ideal dipole approximation. See, ideal dipole approximation means what? Your size of dipole becomes small. So if you reduce the size of your dipole, it means what? 2a is getting reduced? Yes or no? If you shorten your dipole, yes, it will get reduced. Good, Fahad. So see, what will it be? Your dipole size is getting reduced. It means separation between the charges is getting reduced. 2a is getting reduced. If 2a is getting reduced, mean that separation r that we had taken, that is becoming greater now than a. Ideal dipole approximation basically means your size of dipole is small. Size of dipole is small. It means r becomes very much greater than a, because 2a is small now. A is very small. So r is comparatively bigger than a. If your r is very, very big than a, see, look at the denominator. Denominator was what? R square minus a square to the power whole square. See, if I have r as 10, for example, r as 10 and a as 1, Just take this example. Now you're able to see R is big, A is small. A is 1, R is 10. If you square it, R square becomes 100. A square becomes 1. So R square minus A square becomes what? R square minus A square becomes 100 minus 1, which is 99. So 99 is approximately equal to 100 only, no? If you have to approximate it. Just taking an example. 100 and 99 are different numbers, but they just have very less difference in them. 99 can almost be round, if you round off 99, how will you round it off? You will write it as 100 only. It means what? We are getting R square back, because you have subtracted a very small quantity from a very big thing. Like if you're taking a drop from an ocean, the ocean won't get any effect. So R square minus A square can also almost be written equal to R square only. Reason? R square is huge. A square is so less in front of A. So even if you subtract A from R square, there won't be any effect of R on R square. So R square minus A square can be written as R square only. Now if you put it, R is the length between Q and minus Q. No, Fahad. R is the separation. I'll write down. Let me write it down over here. See, R is the separation between center of dipole, this center of dipole, see, this R. Here we had taken R. To the point at which we are calculating electric field, to the point where electric field is calculated. 2A is the separation between plus Q and minus Q. Fahad, is this clear? All right. R is, don't take R as the length of dipole. R will be given to you in the question. So if R square minus A square is almost equal to R square, what does our formula become now? Our formula was electric field came out to be 2 kp divided by 2 kpr divided by R square minus A square to the power whole square. So instead of writing R square minus A square, I can write it as R square. So what will it be? 2 kpr divided by, this can be written as R square. I have written R square minus A square as what? R square to the power square. So this becomes 2 kpr divided by R to the power 4. 1 R will cancel this power and cube will left. So electric field will be what? 2 kp divided by R cube. This is for axial line. And if I ask you, what is the direction of electric field because of this axial line? What is the direction of electric field? Whatever is the direction of dipole, no, that will be the same for axial. If you see your point is lying on axial line, your formula becomes what? 2 kpr divided by R square minus A square to the power whole square. If you see R is very much greater than A, for example, if you're saying R is 10 meters, A is 1 millimeter, if you're able to see this much difference, then you are using this formula 2 kp divided by R cube. Apart from this, this will give you the magnitude. No, but electric field is a vector quantity. It means there is some direction as well. Whatever is the direction of dipole, that becomes the direction of electric field. For example, I'll tell you in this. Or let me take another. Here it will become messy. This is plus Q, this is minus Q. These are the charges. Direction of dipole moment is where? From the negative charge to the positive charge. So if I give you a point, let's say I've given you this point. This point you have identified that it is lying on the axial line. I'm asking you what is the electric field. See, electric field will be from the negative charge to the positive charge. This will be the direction of dipole moment. This will be only the direction of electric field for axial line. If I'm saying this point is lying on the axis of it, so direction of electric field will be this only. So direction of electric field is same as that of dipole moment. That's why we had done dipole moments direction in the previous class. Dipole's moment direction, remember. Bring yourself on the negative charge, start moving towards the positive charge. All right, so this is a derivation. This looks long, but this is not so difficult. Just take the electric fields, add them, you'll get the answer. All right, so start noting it down, then we'll do another case. Electric field for equatorial. That will be the last case for dipole. Then we'll move on to next topic. Madiha, you were talking about your exam which was coming. Is chapter 3 also coming in there, Madiha? Or only the first and second chapters are coming?
No, ma'am, only first and second is there. Third is not.
Okay. Okay.
Ma'am,
Yes, Rifat.
even my exam is on 22nd.
Your exam is 22nd. So what is the syllabus?
The first and second.
First and second. And Fahad, your is all on 21st June and the syllabus is first and second. All right. So no worries. First and second chapters will get completed by that time, most probably. We are at towards the end of the first chapter only. Gauss theorem will be covered. Electric field lines and Gauss law will be covered in the next class. So hopefully we'll begin with the second chapter. And even by that time, if you need extra classes, then classes will be arranged for you. Just remind me before your exam once, whenever you people are having your exams. Then I think your summer vacations will begin, no? Right now, your school is currently going on. Okay, 30th June is the last day for you. Fine. Yes, Fahad, we have done cross multiplication because see, how to solve this when you have numbers in given in denominators? Then we take the LCM, no? If we multiply both of them and whatever is missing, we multiply it there. So that's why we have done cross multiplication, just to take out the LCM. Which one, Fahad? 2A, which one? Two A is the separation between the positive charge and the negative charge. Which one? Just let me know. Okay, this one. This one you're asking for hard. See, I have written KQ as well. I have written this KQ as well. K is also there, Q. It's just that I wanted to tell you that Q multiplied by 2A gives you dipole. So if I write K, Q, 4AR, if I write it as K, if I write this as 2A multiplied by 2, and then I write KNR, that gives me what? This is still giving me 4AR only. Q, Q, K, K. 4A, this is 4A. R is there. These are same only. And it's just that Q multiplied by 2A. This whole is dipole moment. So this I have substituted with dipole moment. Rest of the things are same. Yes, so it becomes P. Good, correct. See, Fahad, what happens mainly in your exams, no, this derivation becomes important. So, questions on this, mainly you won't be able to identify whether it is in axial or they are connected in equatorial. So there you have to identify whether the series they are connected in equatorial or they are connected in parallel, means your electric field, electric dipole. So resultant, you have to remember questions come directly formula based. So we'll do one question where we'll identify how, if they are connected in, or if the point is given you at axial, or if the point is given to you at equatorial, how will you identify? All right, so we'll do one question on it. Otherwise, what happens, rest of the questions are formula based. Dipole moment will be given to you, charge in terms of charge and 2A. K is always 9 into 10 to the power 9. R is something. So that will come formula based only. We'll discuss it. Let's just discuss equatorial line, then we'll see how do questions come. Both mixed. Now see, axial line you have understood. How to identify axial line? If you have the axis of dipole and if the point is given to you there and you have to calculate the electric field, it will be electric field on the axial line. Now equatorial line, this is your second case. Electric field on equatorial line of dipole. Now, how to identify this is important. Otherwise, the questions will be formula based. They'll give you questions on it. They'll give you the values, Q value, P value, K value, R value. You just have to put it in the formula. Main thing you have to identify whether it is connected in series on, whether it is connected in equatorial line or it is connected in axial. Your point is connected to the dipole, whether in axial form or equatorial form. So see, if this is your dipole, let's say this is minus q, this is some plus q charge. These are both, these are forming your dipole, and your point is lying perpendicularly to your dipole. This is your dipole, minus q and plus q. Your point where you have to find out the electric field, this is lying perpendicular to it. Then this becomes your case of equatorial. Now how to identify it? By simply drop it. This is your R now. Separation from the center of dipole to the point at which we are calculating. Remember, this was R only in case of axial. Separation between the center of dipole to the point. Here also, separation between the center of dipole to the point. Now we just have to find out the electric fields. See, electric field, because of this charge, minus Q, it will move towards the charge in this manner. For this charge, negative, it will move away for it. This will be E plus, this will be E minus. How I have written this? E plus is because it is, we are moving away from it. This is your charge. We are moving away from this charge. E minus, we are moving towards this charge. This is your now electric fields. Now we have to solve them. Otherwise, here your answer is there. You know the electric fields, you have to find the solution. Now see, if I say this angle is theta, this angle is theta. So if this angle is theta, according to alternate angle, this will also be theta. This will also be theta. So what should I do? I should use resolution of vectors. That is better to solve my answer. How to get electric fields. So all those who have forgotten how to use resolution of vectors, I am discussing it here right now. Whatever angle it is making with the axis, no, that becomes your cos theta, and the perpendicular to it becomes your sin theta. This you must have done it in your 11th standard only, but let's revise it. Let me redraw it. See, this is your perpendicular and this is your x-axis, y-axis. All right. This is your electric field, E plus, with angle it is making theta. This is E negative, angle, all these angles are what? These angles are theta. Now, all those who have forgotten resolution of vectors, for you people, I'm drawing it separately. Otherwise, you can make it on this triangle only. You will get the result over there. See, E plus, let us resolve it. If this is your theta, or let us take one angle only, it will become confusing. Let's take this angle. This is your angle theta. The angle with the axis which it is making, the axis with which the angle has been made by the vector, that becomes cos theta. So this will be E plus cos theta. We have resolved this. And the perpendicular to it, this becomes what? Your sin theta. This becomes E plus sin theta. All right. Now, talking about the other one. This was E minus, so it will form E minus cos theta because this axis is forming the angle, and the perpendicular to it, this axis, this will become E minus sin theta. First, tell me all of you, resolution of vectors is clear till here or not, or should I repeat once more?
Ma'am, once more, can you?
I'm repeating. See, Yes, yes, I'm repeating. See, this is, let me show it over here. Look at here. Here it is given already. This is your vector E plus angle it is making with this axis, theta. So the axis with which the angle is made with the vector, that becomes your cos theta. So this will become what? This will become E plus cos theta. Perpendicular to it becomes sine theta. So this becomes E plus sine theta. We have resolved E plus. How? This was vector E plus this was theta. So this became E plus cos theta and the perpendicular became E plus sine theta. Now the other vector E minus. Let me draw it with red pen. This is E minus. This is the angle with the axis it is making. This will become what? This will become E minus cos theta. Cos theta, why? The axis with which the vector makes an angle, that becomes your cos theta. And the perpendicular to it is this. This becomes E minus sine theta. What did I do? This was my vector E minus. This was the angle it was making. So angle it is making. So this will definitely be cos theta. This becomes E minus cos theta. And perpendicular to it, other one, this becomes sine theta. Now tell me, is it clear?
Yes, ma'am.
No, not we are not
Yes,
subtracting,
ma'am.
Fahad. Okay, Fahad, we are not subtracting. Minus just trying to represent that electric field for the negative charge, because otherwise you won't be able to differentiate, no, whether it is electric field because of positive charge or negative charge. We are not subtracting. Remember, everyone, it is not E plus sine theta or E minus sine theta. It's just that we are representing electric field because of positive charge, electric field because of negative charge. All right. Now resolution of vectors is clear. If you are still having doubts, when you will start writing it down, no, you can ask me again. Now this is what? This will be A, because dipole separation is 2A. So half of it will be A. If this is R and this is A, then use Pythagoras theorem to find out this. This will be what? R square plus A square, and this side will also be R square plus A square. I'm repeating how I have written R square plus A square. This was R, this was A. I had to find out this side. So it will be what? This was A, this was R. Pythagoras theorem says what? Hypotenuse square is under root, means square of the perpendicular plus the square of base. So square of perpendicular is R square. This is your hypotenuse plus A square. Similarly, this will be for this side of the triangle as well. This will be R square plus A square using your Pythagoras theorem, normal, your previous classes Pythagoras theorem, because we want to know the separation between the charge and that point. No, that's why we have written why is this separation required. Otherwise, we would have used R and A. But see, in this case, what is happening? We don't know the separation between the charges. In the previous case, in case of axial line, we knew the separation between the charges. How? From positive charge to the point, we added R plus A. For the negative charge, we subtracted R with A. We got the separation between charge and point. In this also, we require the separation from charge and the point. Why? Because electric field is what? KQ by R. R is what? R is the separation between the point and the charge which we are calculating. So electric field will be what? Electric field for the positive charge, that becomes KQ by R square. So it becomes square of what? R square plus A square under root whole square. KQ by R square. R is what? Under root R square plus A square. So this is your E plus. Similarly, you have E minus. E minus means electric field for the negative charge. KQ by under root R square plus A square whole square. So we can write R square plus A whole square as R square plus A whole square. This becomes KQ by R square plus A square. This becomes what? KQ by R square plus A square. Now we have the magnitudes. Now just look at one thing. E sine theta is going up and the other E negative sine theta, this is going down. Yes, because root and square gets cancelled. Good, Fahad. That's why we have written it. So E plus sine theta is going upwards, E minus sine theta is going upwards. And we had seen magnitude of E plus and E minus, both are same, KQ by R square plus A square. So if at this point electric field sine theta is there for the positive charge and electric field sine theta is there for the negative charge, both are getting cancelled. It means across y-axis, your net electric field for y-axis is 0. Both are getting cancelled. But look at the x-axis. Electric field for cos theta because of positive charge and electric field cos theta because of negative charge. Both are getting added in the same direction. Means they are not getting cancelled. Here they will get added up. So electric field will be what? This was your electric field, no? Two electric fields are there, E cos theta, E cos theta. One for positive charge, one for negative charge. Here they are adding together. It means we have to add them. So you will get the net electric field across x-axis. That is this as 2E cos theta. E cos theta plus E cos theta. Now E we know, E we have seen, E is KQ by R, so it will be KQ by R square plus A square. But what about cos theta? We need to find cos theta, no? So let us look at this triangle only, the triangle with which the help we calculated the side. If your angle this was theta and I write cos theta, what will cos theta be? All of you write me in the chat box. This is your triangle, this is your theta, this side is R, this side is A, this side is under root R square plus A square. What will be cos theta? All of you answer quickly. Reem, Madiha, Samia, Rifat, Fahad. Cos theta, Fahad, cos theta. How do you write cos theta? This is hypotenuse, this is base, this is perpendicular. Cos theta is written Reem, can you try? Okay, Reem, I'll help you. Just try yourself. Just try once, I'll help you with it. See, cos theta is written how? Cos theta is written by base upon hypotenuse. So it should be base by hypotenuse. Yes, Madiha. So it will be A is the base. A divided by, Madiha, you tell me.
A divided by H or A divided by under root R square plus A
Plus
square.
A square. Good, Madiha. See, it will be base divided by hypotenuse. Base is your A, hypotenuse is R square, under root R square plus A square. So your cos theta becomes what? Cos theta becomes A by under root R square plus A square. Now let us put everything in the net electric field that we have. This will be the net electric field, no? Because net electric field because of y-axis is 0. So all the electric field is due to the x-axis. Net electric field becomes 2 times. Electric field was KQ divided by R square plus A square. Cos theta is A by under root R square plus A square. Now let's just simplify it. This is 2K. From here, if you see 2 K, Q and A. If I write it as Q multiplied by 2A together and K is left. And in the denominator, this is to the power 1 and this is to the power half. So this becomes R square plus A square to the power 3 by 2. What is Q multiplied by 2A?
Dipole.
Dipole moment. So electric field is what? Electric field is coming out to be, yes, dipole. So it will come out to be Kp divided by r square plus a square to the power 3 by 2. This is your derivation for equatorial. So remember these two derivations. These are quite lengthy derivations. We'll see torque. Torque's derivation is very easy. A very short derivation that will utilize dipole. But electric field due to axial point and equatorial point, this becomes lengthy. Now, if you apply dipole approximation, ideal dipole approximation in this, it means what? R is very, very greater than A. So R square plus A square can approximately be written as R square. Why? If you add 1 in 1,000, what will you write? 1,001. So if you round it off, that will almost be equal to 1,000. So it means R square plus A square can be written as R square. Now just put it. You will see electric field as what? Kp divided by, instead of r square plus a square, I am writing r square to the power 3 by 2. Again, this power 2 gets cancelled. This electric field becomes Kp divided by r cube. This is your 3 by 2 this manner. I'll show you. 3 by 2 in this manner. What is the power? This is r square plus a square to the power 1. And whenever you write under root, it means the power is half. So the power is r square plus a square to the power half. Half plus 1 is what? 3 by 2. So how do you write it? You can write it as r square plus a square to the power 3 by 2. Is it clear, Fahad, now? Okay. So this is your equatorial case. Last thing regarding the direction, just opposite to that of dipole. In axial line, what we were getting, whatever direction of dipole is there, that becomes your direction of electric field. But if you're having equatorial point, then whatever direction of dipole you're getting, just make the opposite of it. For example, if this is minus q charge, this is plus q charge. Direction, and this is my equatorial point. Direction of dipole will be what? This will be the direction of dipole from the negative charge to the positive charge. So direction of electric field will be what? Opposite to it. If my dipole is towards the right, then the direction of electric field will be towards the left in this manner. So direction of electric field due to equatorial point is opposite to that of dipole moment. Opposite to that of dipole moment. So note it down, then we'll do a question, how to use axial concept and equatorial concept both. Yes, because of positive charge, not only because of positive charge, Father, it's just a standard way. For equatorial and axial, you just have to remember. But just remember the directions of dipole. For dipole, you should not forget. This is electric field on the equatorial line.
Ma'am, can you scroll a bit up?
And while writing down, if you're still not able to understand any part, if you're not able to recall what was said, just ask me. I'll explain you again.
Then, ma'am. Ma'am, can you explain y-axis and x-axis again?
X-axis in this portion, Samya?
Yes, ma'am.
See, Samya, see. When we had resolved the vector, whenever you are resolving vectors, no, it's always better that you get the resultant by solving x-axis separately and y-axis separately. So what we had seen, if you see the y-axis, in this diagram, if you see, or even in this, you see what you see? Electric fields for sine theta, both of them are in exactly 180 degrees. Both of them are opposite to each other in this manner. And the magnitude is also same, kq divided by r square plus a square. This what we had seen. This magnitude is also same. It means both are same vector. For example, if I tell you 5 Newton above and 5 Newton below, net force will be what? 0. Yes or no, Samya?
Yeah.
So similarly, that's why electric field for y-axis came out to be 0. Regarding x-axis, what happened? E cos theta is there, another E cos theta is getting added. So it's like E cos theta plus E cos theta. This is your net electric field across the x-axis. That's why I written it as 2E cos theta. Because these are in the same direction, it means they are getting added. Yes, it gets added. All right, Samya, is it clear now? In x-axis, it's a under root r square plus a square. In x-axis means here, electric field is kq by r square plus a square, and cos theta is a by r square plus a square. Yes, yes. Here, no, Fahad. So, yes, what is your doubt, Fahad? This A you are asking? This is from cos theta. Cos theta from your right angle triangle. Cos theta is what? This is base divided by hypotenuse. And what is the base? Base is A. So A divided by under root A is r square plus h square. That is cos theta. Because we don't know what is the value of cos theta. That's why we have elaborated cos theta's value from the triangle which we have. So it becomes A divided by under root r square plus a square. Clear? Samya, regarding Coulomb's law at vector form, if you want, I will do it again also. But what the derivation you have done, no, in your syllabus, basically just you add a unit vector r cap just to show its direction. That becomes your Coulomb's law in vector form. So it's the same. Otherwise,
Okay.
if you want, after the end of the chapter also, I'll show you how it is the same. It's same actually. You just add a unit vector to represent its direction.
So, ma'am, it won't be used for numericals, right?
No, it won't be used. It won't be.
Okay.
You will just be using k, q1, q2 by r squared. Direction, you know how to calculate the direction. No, for positive charge, if positive and negative charges are there, they'll attract each other. Like unlike charges, they attract, like charges they repel. So that will give you the direction, and magnitude is given through that Coulomb's law which we have, k q1 q2 by r square, where you put the value of k as 9 into 10 to the power 9. Rest of the things you know, you will be able to handle. Okay, now see, I'll give you a question and we'll see how, if two different conditions are given to you, then how do you solve it? For example, this is one dipole given to you. Let's say this is P1. And at this point R, you have to calculate the electric field. This is point A. This separation from the center of dipole to this point, this is given to you as R. You have another dipole, P2. Again, the separation from the center, this is to this point, this is smaller. Now, okay, Samya, starting from you. Samya, tell us, is this point A lying on the axial point of this dipole P1 or on the equatorial point?
Equatorial.
See, look at this dipole, extend the axis. Is it lying on its axis, this point? Look at dipole P1 and this point.
Yes.
So it will be axial.
Axial.
Right, this will be axial line. And for axial line, what is the direction given? Whatever is the direction of dipole moment, that becomes the direction of your electric field. So dipole's direction is given what? Towards the, it is given you towards the right hand side. So electric field at this point, this will be the electric field's direction. Clear till here, all of you?
Yes, ma'am.
All right. Okay, next Madiha. Madiha, just try it for this point and this dipole. Equatorial or axial?
Much equatorial.
Why, Madiha? Look at the axis of this dipole. Is this point lying on its axis?
It's axial. Yeah.
It's axial. It's axial. See, this looks confusing because both the dipoles are drawn at a perpendicular distance to each other. No. So when you look at this question, this appears that for one it is axial, but for the other point it is lying at equatorial. But you have to look at the direction of the dipole as well. No. For this dipole P2, if you extend this axis, then it is lying on the axial point only. Had this point been lying over here in this or over here, then we would have said it is equatorial. It is lying on the axial point only. And for axial point, we have the direction same as that of dipole. Dipole is moving towards up, so your electric field will also move upwards. This will be the electric field. This is E1 because of P1, this is E2. First tell me, is this clear?
Yes, ma'am.
Clear? What about Rifat and Reem? Clear to you?
Yes, ma'am.
Yes, ma'am.
All right. Okay, Father, I'm explaining again. See, this is your dipole. Here is your point. Extend the axis. A is lying on the axis of it, axis of the dipole. It means your A is lying where? A is lying on the axis of your dipole. Means whatever is your dipole, your point is lying on the axis of it. So this becomes your axial line. Dipole's direction is given to you towards the right hand side. P1's direction. Look at the direction of P1. So E1 will also be right hand side because axial point is there. Now let's move to P2. P2. Extend the axis of P2. A is lying where? A is lying on the axis only. It means A is on the axial line only of P2. And for axial line, what do we have? The direction same as that of the dipole. Dipole is towards up, is upwards, P2. So E2 will also be upwards. This is the direction. These are the electric fields you are getting. E2 and this is E1 at this point A. Now clear, Fahad? So it is axial. It will be axial for both of them. This just appears to be equatorial for this. But if you look carefully, the direction of dipole is also this. No, dipole is located slanting way only. That's why this point becomes axial for both of them. Now, axial case, you know, it is 2 kp divided by r cube. So electric field will be what? Yes, yes. If they are perpendicular, it's axial. Not if they are perpendicular. Look at the dipole separately. See P1. A is lying on the axis of P1. Look at A point and P2. A is lying on the axis of P2. That's why they are axial. Not because they are making an angle of 90 degree or something. It's just that take the point, check whether it is lying on the axis. If not on the axis, check whether it is lying perpendicularly. Either it will be the case from both of them. So this will be what? E net will be 2 kp divided by r cube. This was your formula. So it becomes 2 kp1 divided by r cube. Now E1 is directed towards the right hand side. Rifat, tell me the unit vector for it. I cap, j cap, k cap, minus I cap. Which one should come, Rifat? For positive x-axis?
I
Cap. Good. It will be I cap. Plus this will be 2 kp2 divided by r cube, and upwards this will be j cap. So this is your complete answer. If it gives you some values, put it in the formula. Put it in this, you'll get the answer. That's how you have to solve it. That's how you have to identify the points. All right. So now note it down. Which formula? This one? Are you asking about this Fahad? This is not a formula. This is the answer of this question. Electric field E1 will be what? 2 kp1 by r cube. Direction is I cap. Plus electric field E2 will be what? 2 kp2 by r cube. Direction is what? J cap. This is the answer of it. This is not a formula. Don't remember this. Remember only 2 kp by r cube for axial line and kp by r cube for equatorial line. Written all of you? Just let me know once you have done.
Done, ma'am.
All right. Now see, before moving into the details of torque, one thing let us just revise: cross products. So in cross products, what happens if you have three vectors? Like if you have I cap, you have j cap, you have k cap. You multiply and that gives you the third one. For example, start moving clockwise. If you multiply I cross j, this gives you k cap, the third vector. If you just intershift it, you multiply j cross I, that doesn't give you k cap, it gives you minus k cap. If you move from j cap to k cap, this is all your 11 standards only. I'm just revising for all those who have forgotten it. J cap cross k cap, this gives you what? The third one left, I cap. Shift it. This gives you k cap cross j cap gives you minus I cap. So intershifting the digits brings you a different answer. K cap cross I cap, k cap cross I cap, this gives you j cap. Reverse it, I cap cross k cap, that gives you minus of j cap. This is your cross product. So all those who have forgotten, just revise once from your 11th standards. You must have done. It is basically multiplication of two vectors. Multiplication of two vectors. And the result is always a vector. Result is a vector. For example, if I say I have vector B, I have vector A, angle between them is theta. So A cross B is given by magnitude of A, magnitude of B, and sine theta. If you are now able to recall A cross B, that is A B sine theta. Now, torque is what? Torque is basically rotational analog of force. Whatever force does work in case of linear motions, that when rotate is brought about by rotational forces, then we call it as torque. That's the rotational analog of force. Now, whatever dipole is there, dipole is experiencing electric field. So dipole is also experiencing one torque. So the torque of dipole that we'll see. See, the derivation is very easy. Derivation of this is easy. It's not lengthier and longer like electric field for axial and equatorial point. For torque, this is a very short derivation. See how will we derive it? Let's say these are electric field lines kept. This is one charge minus Q. This is one charge plus Q. Now for electric field and force, this will be the force on it. This will be the force on it. F is equal to QE and F is equal to minus QE. If you remember this formula we have done in our initial classes only, electric field is force by charge. So force will be what? Charge multiplied by electric field. And all these are electric field lines. All these are electric field lines. These are electric field. All these are electric field lines. All right, Q is the charge and 2A is the separation between the charges because the length of the dipole is always taken as 2A. Now, torque is what? Torque is basically force and product of what? Cross product R cross F. Torque is basically, I think now you'll be able to recall from your 11th. R cross F. R is what? R is the perpendicular distance. This is R. This perpendicular distance. Perpendicular distance from where? Let's name this point as some point N. This is A point. This is B point. Let's name this point as N. So this BN, this is your perpendicular distance. But we only know 2A. We don't know what is this distance. So what can be done is, if we take angle sine theta, if I take theta, so sine theta will be what? Sine theta is perpendicular divided by hypotenuse. What is the perpendicular? The perpendicular is this BN. This is the perpendicular. This is BN. Divided by hypotenuse. What is the hypotenuse in this triangle? This longest side is the hypotenuse. This is 2A. So Bn is equal to 2A, which is equal to sine theta. Now can I write Bn? Bn is equal to what? Bn is equal to 2A sine theta. Now I have the value of R with me. R is what? Bn, which is equal to 2A sine theta. And regarding the force, force is QE. So I have value of force with me now. I have value of R with me now. I just have to multiply them and write. So torque is what? Torque is multiplication of force, means QE, with this 2A sine theta. Now let me reassemble it. If I assemble it, it becomes Q2A E sine theta. What is Q multiplied by 2A again?
Dipole moment.
Dipole moment. So torque becomes what? This becomes PE sine theta. And I have told you what is written. Yes, P is the dipole moment. Good, Fahad. So I have told you, if you have such a case, AB sine theta, the weight is PE sine theta. It means this is your cross product. Torque becomes what? This becomes P cross E. This is your torque experienced by dipole. P cross E or PE sine theta. All right, so quickly write this as well. Just write me done in the chat box so I'll know all of you have written. Yes, Fahad. See, F is equal to minus Q is basically what? If you remember, I had done electric field with you. Electric field was what? Force experienced by unit positive test charge. So force will be what? It will be QE. Since we are just talking about this negative charge, so as to distinguish it, that is the force experienced by negative charge. I have written it as a negative sign. Otherwise, see, constantly we are using QE only. Okay, so done all of you?
Yes, ma'am.
What about others? Rifat, Madiha, Fahad? Okay, done. Rifat?
Done.
All right. So if you have any doubts, ask me. Otherwise, in the next class also. So see, we are left with very few topics. Regarding the question of torque, we'll do the numerical in the next class only because we are now lacking time. So in the next class, we'll discuss the numerical of it. We have to discuss electric field lines and then we'll move on to Gauss law. So 1 or 2 classes, then you can start preparing for your exams from first chapter at least. Then second chapter will move on along hand in hand. All right. Okay. So I'm stopping here. If you have doubts, ask